This is 6.8, lesson 1, and for this lesson we are going to convert between scientific notation and standard form. So we're going to fill out the table first. We have 4.7 times 10 to the first. This is actually a number that is written in scientific notation. So 4.7 times 10 to the first is really we're just multiplying by 10 and we get 47. 4.7 times 10 squared, we're multiplying by 100 and we get 470. 4.7 times 10 to the third is like multiplying by 1,000 and we get 4,700. And then 4.7 times 10 to the fourth is like multiplying by 10,000 and so we get 47,000. We can also do this with negative exponents. So again, this is in scientific notation. So everything that's underlined is scientific notation. We know that 10 to the negative first is the same thing as 1 over 10. So 4.7 times 1 over 10 is actually 0.47. 4.7 times 10 to the negative second is 0.047. 4.7 times 10 to the negative third is 0.0047. And 4.7 times 10 to the negative fourth is 0.00047. So I want us to notice a few things. So it says, if 4.7 is multiplied by a positive power of 10, what is the relationship that exists between the decimal point's new position and the exponent? So if we look at our first one here, we went from 4.7 to 47, where my decimal is behind the 7. Well, we see that my decimal moved 1 to the right. When we go to the next one, I go from 4.7 to 470, my decimal moves 2 to the right. 4.7 to 4,700 is 3 to the right. So I want you to notice that the numbers that my decimal moves is the same as our exponent. And whenever it's positive, it means we move to the right. So we're going to say we move to the right the same number as the exponent number. Then when we look at negative exponents, I went from 4.7 to 0.47. So I moved my decimal 1 to the left. My next one I moved 2 to the left. So negative powers mean that we move left the number or the same number as the exponent number. Something that's also special about scientific notation. So if you notice here at the top, we have a number times 10 to a power. Scientific notation is always written as a product of a number times 10 to a power. What's also special is the factor that's in front, the number that's in front, must be greater than or equal to 1 and less than 10. So I say the number in front has to be in between 1 and 10. So looking at these down here, we're going to write in standard form. Standard form is just our regular numbers. So at the top, that was our 47, our 470. All those are standard form. So I have 5.34 times 10 to the fourth. Since it's a positive 4, it means I move my decimal 4 to the right. So 1, 2, 3, 4. So my final answer is going to be 53,400. So if we do all of our positives, letter C, I move my decimal 5 to the right, so 1, 2, 3, 4, 5. So I get 742,000 as my answer. And then for letter E, I move my decimal 2 to the right, so I get 371.4. Letter B, we have a negative exponent, which means we move our decimal to the left. So in this case, I'm going to move my decimal left 3. So 1, 2, 3. Where I don't have numbers, I fill in with zeros. So I have 2 zeros and then a 3, 2, 7. And then letter D, I move 2 to the left. So I have 0.061. On the back, we're gonna do the reverse. So I'm gonna give you a standard form number and you have to change it to scientific. So remember, for scientific notation, I need a starting factor that is in between 1 and 10. So I have this number, 3,725,000, and I need to create a number that is in between 1 and 10 just by moving my decimal. My decimal starts off here, and I'm gonna move it left until I find a number that is in between 1 and 10. So I'm going to end up having to move it 1, 2, 3, 4, 5, 6 places. So that gives me the number 3.725 times 10 to the 6th power. When I have large numbers bigger than 10 that I start off with, my exponent is going to be positive. When I have small numbers that are less than 1, my exponent is going to be negative. So in this case, I need to move my decimal 1, 2, 3, 4 places, 3.16 times 10, but this one is to the negative 4th power. Letter H, I need to move my decimal 1, 2, 3, 4, 5, 6, 7 places, so 1.414 times 10 to the 7th power. Letter I need to move my decimal 3 places, so it's in between 8 and 7. So that's going to be times 10 to the negative 3rd power. And then letter J, I only need to move my decimal 1 place, so I have 1.14. This is times 10 to the negative 1st. Letter K says refer to the table and order the countries according to the amount of money visitors spent from greatest to least. So when we have to order these from greatest to least, we could change them all to standard form and compare, or I can compare while they're still in scientific notation. And the first thing I need to look at is my exponents. Since I'm going greatest to least, my biggest numbers are going to have the biggest exponents. Well, my biggest exponent is 7, and I have 2 numbers that have an exponent of 7. So then to figure out which one's bigger, I go and look at my starting factor. And 1.06 is bigger than 1.03, which makes the UK a greater number. So then Canada is going to be second. Both of our next numbers have an exponent of 6. So then we look at their starting values. Mexico's is larger, and then India. For letter L, we're doing it from least to greatest. So I need to find my smallest exponents, which is 5. They have the same exponent, so I look at my beginning number, and Boston is smaller. So then DC will be next. My next exponents are 6, so I look at my beginning numbers. And again, I'm going least to greatest, so Las Vegas is my next smallest. And then LA is our last one.